Number one. Number one's a little tricky. Number one says the student graphs the system shown below. Well, I kind of moved the graph to the right, sorry. Oh, wait, no, the system's right here. The system here. Describe and correct the student's error. Lots and lots of practice. So the first equation says x minus y is greater than or equal to 3. So what I'm going to do is I'm going to solve that for y, and I'm going to graph it and see if it matches. Okay? So we have x minus y is greater than or equal to 3. So I'm going to subtract x from both sides. And that gives me negative y is greater than or equal to 3 minus x. Then I can divide everything by negative 1. Because that's a negative 1 in front of the y, right? What's negative 1 divided by negative 1? Positive 1. So I have positive 1y. But what happens to my inequality when I divide by a negative? It flips, is less than or equal to negative 3 plus x. All right. So if I graph this, I'm going to go to the y-axis at negative 3. Okay, so far so good. And my slope is positive 1, so I'm going to go up 1, bless you. Up 1 over 1, up 1 over 1, up 1 over 1. So my line looks pretty. It looks like all the points are where they're supposed to be, right? All right, it says y is less than or equal to, so that's going to be what kind of line? Solid line. And if it's less than, we're going to shade below. So is the first graph okay? There's nothing wrong with the first graph. All right, let's take a look at that second graph. It says y is less than negative 2. So I'm going to go to the y-axis at negative 2. All right. Less than means they're going to draw a dotted line, right? And they've got a dotted line. And y is less than means we're going to graph below. We're going to shade below. So the second equation looks fine, doesn't it? So far, so good? All right, let's take a look at that third equation. You think they're all okay? Let's see. So it says y is greater than or equal to 1. So I'm going to go to the y-axis at positive 1. Okay. Greater than or equal to means I'm going to draw a solid vertical line, right? Greater than means we're going to shade which way? Left or right? Greater than, which way is greater? To the right. Which way did they shade? Left. They shaded left. So you already can say x is greater than or equal to 1 is shaded. Oh, sorry. I'll do it in a different color. I apologize. Is that a better color? X is greater than or equal to 1 is shaded on the wrong side. So my solution set should be this area right down here, right? Where all three are, that bottom right corner. All right, number 2. The directions for 2 and 3 says determine whether the ordered pair is a solution to the system. So remember, to determine if an ordered pair is a solution, we're going to plug in x and y and check both inequalities. If it's true for both, it's a solution. If it's not true for even one, it's not a solution, right? All right, so let's plug in here. So number 2, my x value is 0. My y value is 1. So in the first inequality, I'm going to have 1 minus 0 is greater than or equal to 3 times 1. Okay, what is 1 minus 0? 1. So 1 is greater than or equal to 3 times 1 is 3. Is 1 greater than or equal to 3? No. So this is not true. So is 0, 1 a solution to the system? No. 0, 1 is not a solution. All right. Number 3. 3, my solution point is -3, -3. So my x value is -3. My y value is -3. So I'm going to plug those both in to both equations. So I have 5x, so 5 times -3. Plus 4y, y is -3 also, is greater than -4. Five times -3 is -15. 4 times -3 is -12. Is -12 greater than -4? Well, -15 minus 12 is -27. Is -27 greater than -4? No. Not true. So -3 is not a solution. All right. Number 4 and number 5 are here at the bottom. We're going to do 4 together, and then I want you guys to try 5. You ready? See any pencils still moving? Y'all ready for number 4? One's ready? Okay, I don't want to leave anybody behind. Number 4 says, which system of inequalities is represented by the graph below? So, here I just want to be really clear. I tried to write this on your copies because I knew sometimes the copies, the shading comes out kind of light. It's hard to see. So the solid line is shaded on the left side. That dotted line is shaded below. You all see that? And I can tell that because this darker area here is in the left bottom corner. That's the only way that could be the solution set. Okay, so what I'm going to do is I'm going to write the equation for both of these and then compare it to my answer choices and see which one's true. That's one way to do it, right? Are there other ways to find the solution? Yes, definitely. Could I use my calculator and graph all 4 of those in my calculator and compare? That's a good way. Could I pick a point in the solution set and plug it into all 4 answer choices? Yeah, that would be another way, right? I'm going to write the equation, but you're welcome to use any of those methods, okay? Especially using your calculator to check your answer. If you use another method, it's always nice to use 2 methods, and the calculator is a quick way to check, right? All right, so what I'm going to do is I'm going to write those equations. So the solid line first begins at -2, and then my slope is 3/1. So I'm going to say y 3x minus 2. And it's shaded above, and it's a solid line, so I'm going to say it's greater than or equal to. So right now I'm going to go look at my answer choices and see if that's one of the equations in my answer choices. All right, in A, it says less than or equal to. So I can eliminate A. B says greater than. Bless you. D also says greater than. But C says just greater than, not or equal to. So I can eliminate C. So it's got to be either B or D. Okay. So to write that equation, my dotted line begins at 1, positive 1. My slope is up 1, 2, 3/4. So my slope is 1/4 x. And I'm shaded below, so it's going to be less than. So both B and D have 4y, right? So on B, if I divide, 4y is greater than x plus 4. If I divide each piece by 4, I'm going to get y is greater than 1/4 x plus 1. Does that match what I found? Almost. What's wrong? The inequality. So it can't be B, but let's look at D. What's the only difference on D? That inequality, right? So the answer has to be D. All right, I want you guys to try 5. So on number 5, we worked together in the calculator, and we found that B was the best answer, right? Because A, the dotted line was shaded in the wrong direction. All right. Next page is all about exponent rules. You ready? Don't do that to your calculator, child. All right, let's take a look at number 1. So number 1 says simplify. I've got 3 squared to the -6 power. So when I have an exponent raised to a power, what am I going to do? Multiply. So that's going to be 3 to the 2 times -6. And what's 2 times -6? -12. Oh, look, that's one of my answers, isn't it? Hey. All right. These formulas are all on your formula chart, by the way. So you will have these rules tomorrow on the test. All of these rules that are in that foldable we've been working on are on the formula chart. All right. Number 2. Number 2. Isaiah, you ready? Yeah. So if I have 2 to the 5th over 7 squared raised to the 3rd power, both the numerator and the denominator are also going to get that exponent. So I'm going to rewrite that. 2 to the 5th cubed and 7 squared cubed. Ah, so this is 2 rules, isn't it? All right, so then I'm going to multiply. 3 times 5 is 15. And 2 times 3 is 6. Which answer choice does that match? C. Yes, dear. Number 3 says, simplify 5 to the negative 4th over 5 squared. So the first thing I notice is that I have the same base. Both of my bases are 5. So the rule for dividing is we're going to do what with those exponents? Subtract. So we have 5 to the negative 4 minus 2. What's negative 4 minus 2? 5 to the negative 6. Is that an answer choice? Get your headphones away. I didn't ask. 5 to the negative 6, that's it. All right. Number 4. Number 4. So, if I'm multiplying fractions, I can multiply across, yes? Eyes up here, please. So I'm going to rewrite this. So I have 2 to the 4th times 3 to the negative 2 times 3 to the 4th times 5 to the negative 1 over 5 squared times 2 squared. Okay. Ooh, I have like terms here in my numerator. So if I'm multiplying, what do I do with my exponents? We're going to add. So that's going to simplify. We've got 2 to the 4th, 3 to the, what's negative 2 plus 4? 2. 5 to the negative 1 over 2 squared, 5 squared. All right. So then next, if I'm dividing, I'm going to subtract those exponents, right? So in my numerator, what's 4 minus 2? 2, so positive 2, so that's 2 squared. So then I have 3 squared because there's no 3's, right? And then negative 1 minus 2. Negative 3. But if it's a negative, where can I put it so that exponent is positive? And the denominator, right? It moves down. Does that match any of my answer choices? C. Five is similar. I'm going to leave 5 for you to do, because 5 is similar to 4. 6 we omitted. Let's take a look at 7. Seven says, which of the laws of exponents shown can be used in an explanation of why any number to the 0 power is equal to 1? All right. So A says x to the negative a power is equal to 1 over x to the a. Well, this one is talking about the negative exponents, right? So it's not A. B says x to the a times x to the b results in x to the a plus b. So that's when you're multiplying with the same base, right? So does B describe a 0 exponent? No. And then C is the same rule, but with dividing. So D, none of these. Kind of a trick question. None of those are describing that zero exponent rule, right? All right. Number 8 says, which of these shows why a number to the negative power is equal to the reciprocal of the number? So A says x to the negative a equals 1 over x to the a. Okay. Maybe we have a negative exponent there, right? B, we're dividing x by y. So it's like that a gets distributed, remember? Like everything in the parentheses gets the a. And C is that division rule. We subtract the exponents. So the best answer there is A. All right. 9 and 10 are similar to those last three, so I'm going to leave 9 and 10 for you to do. Let's take a look at number 11. It says rewrite this expression using exponents. So what am I going to do if I'm multiplying t several times? How could I rewrite that condensed?
It's t to the 10th power.
Because how many t's are there? There are 10 of these t's, so we're going to say t to the 10th power.
D.
So the answer would be D. You got it. All right, I'm going to leave 12 for you. 12 is yours to study. Let's take a look at 13 and 14. Thirteen says reduce negative 28x squared y over 7xy squared to lowest terms. So let's take a look first at those constants. So I have negative 28 over 7. Does negative 28 over 7 reduce? Does 7 go into 28 evenly?
Yes.
How many times? Negative 4. All right. Then I have x squared over x, so that's going to be x to the 2 minus 1 power. And y over y squared, so that's y to the 1 minus 2 power. So that's going to give me negative 4, x to the 1, y to the negative 1. Does that match any answer choices? No, but what could I do to make that exponent positive? Put it in the denominator. So I have 4x over y. Does that match? D. There we go. All right. 14. 14. So I have 2x squared y to the negative 1 cubed, x times x to the 5th, all over 2 plus x to the 0 squared, plus 3 to the negative 2 times x squared. Well, first rule, this exponent is going to get distributed to every piece here, yes? So we're going to have 2 cubed x to the, what's 3 times 2? 6th, y to the negative 3rd times x to the 5th over, well, what's x to the 0 power? 1. So I can add 2 plus 1 is 3 squared times 3 to the negative 2 power times x squared. All right, then I can combine, here in my numerator, I have x to the 6th and x to the 5th is going to be x to the 11th, because we're going to add. It's y to the negative 3rd. 2 cubed, what is 2 cubed? Well, 2 times 2 is 4, and then 4 times 2 is 8. And then my denominator, I have 3 squared. 3 times 3 is 9. Oh, wait, I've got another 3, don't I? So I can add these two. So what's negative 2 minus 2? 0. So that's 3 to the 0 power. What's 3 to the 0 power? Hey, look at that. So then I have x squared. All right, so I know my only number is going to be 8, so I can eliminate a and d. That negative 3 makes that y cubed go to the denominator. So all I have to do is take care of this x. So if I'm dividing, what do I do with those exponents? Subtract. So 11 minus 2 is 9. My answer is going to be C. Fantastic. All right. I'm going to leave the rest of these for you guys to complete for homework. These are going to be for you to study for the test tomorrow.